maintenance purpose, the cost will also be high. Am I clear or not? But underground cable, it is very low. Okay. Now coming to the frequency of failure, more chance of fault will be occurring. As I've told you, that if there is a lightning, there is a more chance of fault in the transformer, in the cable, in the transmission towers, in the transmission lines. You will see that the insulators will burst. There will be the transmission towers or the transmitter towers will fall down. Then the transmission lines will be uprooted. Yes or no? Clear or not? So more chances of fault in frequency of failure is more compared to that of underground cable. Now coming to the yes. So this is the transmission towers. This is the earthing wire is at the topmost line, topmost conductor is the earthing wire. These are the cross arms. Okay. And these are the insulators. This is the transmission towers. This is the spatial, some spacing has been kept. Okay. This is a damper winding. I will tell you later on what is the function of the damper winding. And these are the conductors. Okay. And this is the transmission cable. Now coming to the, now continuing the same parameter, the parameters, next is the frequency of accident. Overhead transmission lines will be subjected to high frequency of accident, as I've told you, mainly due to any, suppose a bus is going and it has touched the transmission line. So there will be a number of faults will be occurring at that time. Okay, so there is more frequency of accident compared to the over the ground line. Now coming to the voltage drop, in overhead transmission line, there will be more high voltage drop because the conductors will be subjected to the temperature, to the sun directly. So you know that when the conductors will be under, when there will be a summer season, there will be a lot of loss at that time due to the high increase in the temperature. So the drop will also be more compared to that of the underground line. Now comparing to the appearance, it is not so good, but underground good looking. Good looking means you cannot see. So fault, everywhere you will see that it is nice, not like clumsy like your overhead transmission line. So fault location and repair, it is easy to locate the fault, but it is very difficult to locate the fault in case of underground cable. See, so many advantages as I have told, but this is one of the disadvantages of the underground cable. This is one of the disadvantages of underground cable. What is the one of the disadvantages? It is very difficult to locate the fault. Once the fault has occurred, it is very difficult to locate the fault. Okay. Now the same thing coming to the damage due to the lightning. Here overhead transmission line is having maximum damage compared to that of the underground cable. So after reading the difference between the comparison between overhead transmission lines and underground cable, you got a conclusion that there are some advantages, some disadvantages of both in both the cases, in the overhead transmission line as well as in the underground cable. So in this case, but conclusion is a number of advantages we can get it in case of underground cable. Okay, number of advantages we can get it in the underground cable, but still India is lagging behind using the underground cable because of the cost factor. Because a lot of initial cost is required everywhere, but in most of the cases, those were living in metro cities. In most of the cities, they are underground cable. In Bhubaneswar also underground cable is under the construction. Yes or no? Yes or no? What it all of
Yes, ma'am.
Yes, ma'am.
Yes. So due to so many advantages, we'll prefer underground cable rather than transmission lines, rather than overhead transmission lines. So now coming to the comparison between AC and DC distribution system. What is AC and what is DC? Just tell me the full form of what is AC and what is DC. Tell me.
Alternating
Alternating current and direct current.
Okay. Alternating current and direct current. What is the difference between alternating current and direct current? Whatever you have read, tell me. Whatever you have idea about the alternating current, whatever you have idea about the direct current, tell me. How
Ma'am,
you
direct current
define?
is ma'am, direct
Yes.
current is constant flow of electrons.
Yeah, ma'am. No frequency changes in AC. There is frequency changes are there.
Yes, ma'am.
Yes. Any other
The electron
answer?
And alternating current with direction change होती है, direct में नहीं होती.
Any other answer? All of you are near to the answer, but somebody will ask you, na, your answer should be very clear within one sentence. The answer should be very clear and it should be what? It should be within very less words you have to answer. Yes, tell me.
In AC, the flow of current changes periodically, while in DC, the flow of current is steady.
Okay. Next, any? I require more answer, more accurate answer.
DC flows in only one direction, while as AC changes its direction periodically.
Okay. Everyone has approach to the answer. Any more answer? AC, what? How you define? Somebody will ask you, define what is AC. AC voltage or AC current. How you define? Yes, tell me. Whatever you know, tell me. Let me know.
Ma'am,
Ma'am,
if the voltage oscillates between positive and negative, then it is called AC.
voltage oscillate between positive and negative. So when you are speaking about this positive negative, that is not clear. What is positive, what is negative, it is not clear. What is positive, what is negative? What is positive, negative, you have to define them. Yes, any other answer?
I mean, AC, the electron oscillates at a point, and
Yes,
DC,
electrons oscillates
electron
at the point, but DC,
electron flows in one direction.
electrons flows in one direction. Any other?
Ma'am,
Well,
efficiency of DC is high.
efficiency of DC is high. Why?
Ma'am, more energy efficient, that is.
No,
AC current, AC
our
current.
efficient.
The direction in which the electrons flow is the difference, I guess. In the AC,
There's no zero frequency in DC, and there's a certain frequency.
Yeah, ma'am. In regular interval, ma'am.
I mean DC it flows in a single direction steadily, while in AC it flows periodically backwards.
you have told so many answer. I will tell you one answer, and that you have to remember it. That you will remember it within very. I will tell you. Just wait 1 second. When you are talking about AC, okay, their AC is having two things. One is, just wait 1 second. Just wait 1 second. 1 minute. Just wait. I think বোর্ডটা কোনো প্রবলেম হচ্ছে না।
Ma'am, too much background noise.
Too much background noise.
Yes, ma'am.
कुछ तो बैकग्राउंड नॉइज नहीं हो रहा है तुमको कैसे? एक मैडम पढ़ा रही है बस उतना ही, वो साउंड हो रहा है?
No, ma'am, it's fine now.
Okay. So here I will tell you AC, when you will talk about AC is having two things. One is your AC voltage, another one is your AC current. When you will speak about AC, we will be having two things. One is your AC voltage, another one is your AC current. So how you define AC voltage? Tell me. How you define AC voltage? When you are
Periodically
talking, no. When you are talking about voltage, you will speak about its magnitude and you will speak about its polarity. What you will speak? You will speak about its magnitude and you will speak about its polarity. Okay. Now, how you define AC voltage then? AC voltage is that voltage whose magnitude and polarity changes with respect to time. Understood? You will speak about its polarity, you will speak about its magnitude. So how will you define? AC is that voltage whose polarity and or whose magnitude and polarity changes with respect to time. Okay. And similarly, how you define current? When you are speaking about current, you will speak about, I'm having certain issues in my Microsoft board. I'm unable to write. Next class, I will tell you details. So when you will speak about the current, you will speak about the magnitude and you will speak about the direction. D is for direction. And when you are speaking about the voltage, you will speak about the magnitude and you will speak about the polarity. Understood? So when you will define AC voltage or AC current, define like this, that AC voltage is that voltage whose polarity and magnitude changes with respect to time. AC current is that current whose magnitude and direction changes with respect to time. Am I clear to all of you? Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Yes, ma'am. So similarly, when you are discussing about DC, same thing. When you will talk about the polarity, when you will talk about the voltage, then you will talk about the what? Tell me. You will tell about the magnitude and what? Polarity. And when you will discuss about the current, you will discuss about the what? Magnitude and
direction.
DC is that current or DC voltage is that voltage whose magnitude and polarity remains constant with respect to time, and DC current is that current whose magnitude and direction change is constant with respect to time. Am I clear to all of you?
Yes, ma'am.
Understood all of you or not?
Yes, ma'am.
Yes, ma'am.
So here I will discuss about the AC distribution and DC distribution. So AC distribution in three-phase AC distribution system requires 4 wires. Okay, in India we are having 4 wires. One is your R, Y, B, and fourth wire is the neutral wire. Okay, and DC distribution system requires only 1 wire with the ground as the return path, because current has to enter and it has to go out. Okay, that is DC distribution system. So efficiency of transmission, power transmission, efficiency of power transmission is less in case of AC distribution system. DC distribution system efficiency is more. Why? Why, can you tell me? Efficiency of power transmission, whatever idea you are having, tell me. The efficiency of power transmission is less, whereas in DC distribution, voltage drop is less in the distributor due to the absence of, you already know that in case of when you will be using an inductor, if an inductor is there, a capacitor is there, and the supply is a DC, their inductors and capacitors will not work at all if the supply is DC. Okay, again I'm telling you, if the supply system is DC and you have used inductor and capacitor in the system, then it will not work at all. Only resistors will work in the DC system. Whereas in case of a AC system, their inductors, capacitors, and resistors all will work. Okay, DC, when I will start a DC in the next class, I will tell you about all these types of circuit elements. Inductors, capacitors, and resistors. These inductors and capacitors do not work when the system is, or when the supply is DC. Okay, so because there is absence of, or there is no inductors and there is no capacitors, so there is no voltage drop in the inductor and there is no voltage drop in the capacitor. So what happens? The efficiency is little more compared to that of the AC distribution system. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay, very good. So in case of India, actually we are having 3-phase 3-wire and 3-phase 4-wire distribution system. 3-phase 3-wire when the system is connected in delta, you will read later on. 3-phase 4-wire system when it is connected in star. Okay, in our house actually we are having 3-phase 4-wire system. In the transformer where your house will be connected, you will observe carefully that there are having 4 wires. Okay, 3-phase and 4th one is the neutral wire. Okay, but DC distribution system, the transformer cannot be used for improving the voltage level. In AC distribution system, with the help of transformer, we are stepping off the voltage or we are stepping down the voltage, but the DC distribution system, that we cannot do it. We cannot step up the voltage in case of DC distribution system with the help of transformer, because transformer is the main equipment where we are using for transmission as well as for distribution. But you cannot give a DC supply to the transformer to step up the voltage or to decrease the voltage whenever it is required. That means a transformer will not work when the supply is DC. Am I clear to all of you up to this?
Ma'am, can you explain that 3-phase and 4-wire?
3-phase 4-wire system. 3-phase 4-wire system. In case of India, we are actually having, in case of India, we are actually having 3-phase 4-wire system. 3-phase 3-wire system, 3-phase 4-wire system. 3-phase 3-wire system is, we are having R, Y, B, and this one is R, this one is Y, this one is B, and this one is the neutral. Okay, this is a three-phase four-wire system. Three-phase three-wire system is only RYB where the neutral is absent. Okay, in India distribution system we are keeping it is in star connection. This is in case of star connection and this is in case of delta connection. We usually, here are some advantages and disadvantages. In a three-phase circuit, I will be discussing in details. But here I want to tell you, you will see, because we are transmitting three-phase power. Am I clear? Who was asking? Who was asking?
Ma'am, Suprasad.
Suprasad, yes. So in India, we are having a three-phase four-wire system. Why? Because we are generating three-phase power, we are transmitting also three-phase power. Now, when it comes to the distribution side, you must have observed in some cases, your house is getting the supply, other houses are not getting the supply. Or in some cases, you will see that your house is not getting the supply, other house nearby your house, they are getting the supply. Have you ever observed it or not?
Yes,
You
ma'am.
have observed it? Yes. So why it is happening, here you see, if your house is connected between B and N, if your house is connected between B and N, their house may be connected between R and N or Y and N. If you will take the voltage between any line to neutral, this is nothing but the phase voltage. This one we call it as phase voltage. Any line to neutral. In our house, we are getting phase voltage. Either our house is connected between R and N or Y and N or B and N. Suppose your house is connected between R and N, you will see that the neighbor where there is a difference in getting the supply, if some fault is occurring, then their house may be connected between Y and N or B and N, that their house is not connected to R and Y, if your house is connected to R. That means your phase and their phase are different. Am I clear? Phase is what? Between any line to neutral voltage, we call it as phase voltage. BRN, BYN, any line to neutral, BBN, all are the phase voltage. These are the phase voltage. Am I clear?
Yes, ma'am. Yes, ma'am.
Suprasad, here. But line voltage is what? Details I will be discussing. The three-phase circuit is there. Okay. VRY, this is the line voltage. VYB, this is the line voltage. Okay. And VBR, this is the line voltage. Line voltage is little higher than phase voltage. In India, we are having phase voltage as 230 volt. These 230 volt, what we are telling, this is which voltage? This is which voltage? This
Phase
is
voltage.
your phase voltage. Am I clear? Okay.
Yes,
And these are the line voltage. I will be discussing details, I will be discussing, but not in the first module here. So we are having three-phase three-wire system, three-phase four-wire system. Three-phase three-wire is having more voltage. This is, you will see that the relation between the delta and star is actually, in case of star connection, the relation between phase voltage and line voltage is phase voltage is equal to line voltage divided by √3. Divided by √3. Okay, this will come near to 230 volt, which you are getting at your home. Am I clear to you?
Excuse me, ma'am. Ma'am, one more
Tell.
question. Ma'am, why in India we use phase voltage? Means, what was the reason?
In India, we use phase voltage because that amount of voltage is not required. 400 C. Here I want to tell you that here I have written the formula. In star connection, phase voltage is equal to how much? Phase voltage is equal to line voltage divided by √3. This much. Okay. This is now in case of line voltage, we are having in India, we are having line voltage is equal to 400 volt. Okay. This amount of voltage is not required to our house 230 volt, it is enough to give the supply to all the loads. So why we will use 400 volt? Why we will use 400 volt, that is the line voltage. So what we do it is, and here you see, in case of a delta connection, we are not getting 230 volt. You see here, because in case of a delta connection, I will tell you the relation, derivation, I will tell you. V phase equal to VL. Okay, here you cannot get 230 volt in case of delta connection. So, because we require 230 volt and that is enough for us, so we move to the which connection? Star connection.
Yes.
Am I clear?
Star connection. Yes, ma'am, star connection.
Am I clear now?
Yes,
That
ma'am, yes, ma'am.
amount of voltage is not required for our AC, for our bulb, fan, whatever may be the loads we require, that is 230 volt is enough for us. So we do not go for this 400 volt. You will see, I have shown you the slides before. You see here, I have, but nobody has asked me that time. So I just didn't told you at that time. Here you see. Here you see, I have shown you this slide. Here you see. This slide I have shown you, na? Just to see here.
Yes, ma'am.
Just to see here, I have written here secondary distribution 400 volt. I have told you that we are the small consumers, but nobody asked me at that time that, madam, why is 400 volt is not coming to our home, and you are telling that we are the small consumers and we are connected to the secondary distribution. Have you asked? Have anyone of you asked?
No, ma'am.
No, I remember that you have not asked, but I will definitely tell you when I will teach you in the three-phase circuit. So because you didn't ask, I didn't told you in details. I will be telling in the three-phase circuit is there, that I will be telling. Single-phase, three-phase circuit is there, I will tell you everything. Here you see, I have shown you, we are connected to the 400 volt secondary distribution, but these 400 volt which I have told you, na, this is the line voltage. Okay, this 400 volt is the line voltage, and we are taking the power, or our house is connected between one line to neutral. See, the three-phase system is available here. We are having a three-phase system already available, but my house is connected between B and N, where I am getting how much volt? 230 volt. If I will take the voltage between VR and N, if I will take the voltage between VR and Y or Y and B, then you will be getting how much volt? 400 volt. Am I clear now? Your concept is clear or not? Tell me.
Yes, ma'am.
Yes, ma'am.
Okay. Any line voltage between any two lines, VR and Y or VY and B or VB and R, any two lines you take, you will get it as 400 volt. So there, whatever it is mentioned, it as 400 volt, that is the line voltage. Okay, we do not tell about the phase voltage, because we will read later on that the relation between the line voltage and phase voltage is phase voltage equal to line voltage divided by √3. So automatically, where you will know that the line voltage is 400 volt implies that the phase voltage is equal to 230 volt. Am I clear to now?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So here I was discussing about the distribution system. In India, we are having three-phase, four-wire, three-phase, three-wire also. You will see that in the some medium type of consumers, their also connection is also delta. Okay, their 400 volt they are required. They do not require 230 volt. So now coming to that of coming to the components of LT switchgear. Now here you tell me, have you seen these types of switchgear? Have you seen this type of switchgear? Where you have
Yes, ma'am.
seen? Where you have seen? Tell me.
Main board.
Yeah, my main board.
Main board, very good. LT means low tension switchgear. Okay, this is the switch fuse unit. That is, there is no separate fuse and switch unit. There is the complete set is called as the switch fuse unit. There is only the fuse unit which itself acts as a switch. So when you will close this one now, automatically the fuse is also connected to the loads. Okay, the current will flow to the loads through the help of this fuse unit. Through the help of this fuse. Okay, so when we operate it, the fuse unit will close the input and output of the breaker. Switch fuse unit has been used to trip the circuit, particularly for high capacity tripping. Okay, this can trip the circuit for a high capacity tripping when the capacity is very high. Okay, so we call it a switch fuse unit. That means the switch is there, the fuse is also there. Now coming to the second one, that is the miniature circuit breaker. All these are protective devices. This is the miniature circuit breaker. What is a miniature circuit breaker? All of you have seen miniature circuit breaker. Yes or no? Tell me.
Yes, ma'am.
Yes, ma'am.
What is the function of? It automatically switches off if the condition is abnormal, and it will disconnect if there is any failure. What will happen? It will disconnect the circuit. That means it will protect yourself, your loads, okay, and again when you will turn off, again you will clear all these things and you will switch on, again it will make. That means it simply makes the circuit and breaks the circuit. It makes the circuit, it breaks the circuit. It is not like a fuse. Fuse, what you have to do, once it melts, what you have to do? You have to replace it by another fuse wire. Am I clear? Am I correct or not?
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
all of you understand or not?
Yes, ma'am.
Yes, ma'am.
Now coming to the, nowadays we use an MCP in low voltage electrical network instead of a fuse, because fuse, what you have to do, we have to replace it manually, then we have to switch on. Okay, but handling MCP is electrically safer than a fuse. Okay, so quick restoration of supply is not possible in case of a fuse wire, as because fuses must be revariable or replaced for restoring the supply. Restoration is early possible by switching it on, easily possible by switching it on. Now in case of MCP, what happens? You immediately again switch on, then if there is any failure, again it will switch off. Yes or no?
Yes, ma'am.
Yes, ma'am.
So next is your earth leakage circuit breaker. Have you seen this type of circuit breaker? Tell me. Have you seen it or not? Are seen it or not means immediately your answer will be
No, ma'am.
yes.
No,
No,
ma'am.
ma'am.
What is the function of earth leakage circuit breaker? Now, here I will tell you. You must have observed in some cases that some electrician will be coming to your, suppose your freeze is not working, he will come. If you have observed him carefully, I don't think you have observed him carefully, he will, suppose the freeze is always after 2-3 months, it is coming for repair, some problem is coming. Okay, so that electrician he will be bringing this one, earth leakage circuit breaker, and what he will see, he will see by this one earth leakage current measuring device, he will see whether the earth leakage current is there or not. Okay, so this circuit breaker, what it does, if there is any current leakage from any electrical installation, okay, there must be an insulation failure in the electrical circuit, it must be first detected, okay, and it should be prevented. Otherwise, there may be a high chance of electrical shock if anyone touches the installation. Now, if you have observed, if you will touch the washing machine, you get an electric shock. Most of the time. If the earthing is proper, then there is no electrical shock. Otherwise, you will see that in some cases, some appliances, you touch it, there will be you will getting a shock always. Have you ever observed it or not? Anybody
Yes.
have observed?
Yes,
Anybody
ma'am.
have observed? Yes, though observe, you can tell. It's not that everyone has observed. No, it's not like that. In most of the cases, you will see that, suppose in my cases, I have seen that washing machine, always you touch it, within, even if off, there will be you will get a current. You will get a shock. That means there is a problem in the earth leakage. The maximum current, if there is any leakage, that current is not flowing to the ground. Okay, that is flowing in the body of the machine or body of the appliance. So when you are touching the body of the appliance, because the current is not going to the ground, not going to the earth, Okay, that current is circulating in the body of the appliance. So when you touch the body of the appliance, you are getting a shock. Am I clear?
Yes, ma'am.
Okay, so what it does, the earth leakage circuit breaker does it efficiently. What it does, it detect and it prevent it. Okay, it prevent it by disconnecting it. So otherwise that has to be corrected. See, if you are getting a shock in most of the cases in a particular appliance, that you have to correct it. Otherwise there may be a chance of high electrical shock. Okay. That means, so here you see the second point, the earth leakage circuit breaker does it efficient. That means it detects earth leakage current and makes the power supply off by opening the associated circuit breaker. Am I clear to all of you? Each one of you? Each one of you, am I clear?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay. Next is molded case circuit breaker. Molded case circuit breaker, what is its function? Its function is same as that of the miniature circuit breaker. Okay, but it is meant for higher current, higher rated current, and it is usually used in industrial application. Okay, its range is 250 ampere to 800 ampere. Its range is very high. So these type of circuit breakers are used in case of industries. It automatically cut off the electrical power in case of overload and short circuit. If there is any short circuit, it will cut off. If there is an overload, excess load, then it will also cut off. So these type of circuit breaker will operate same as your miniature circuit breaker, but they are used, these are used for high range. Am I clear?
Yes, ma'am.
So now coming to the general rules of wiring. So there are different rules of wiring. One is the wiring circuits are designed for efficient distribution of electrical energy. The requirements of a good wiring circuit design are equal voltage distribution. I have told you 230 volt is coming to your house. We will see that all the appliances are getting 230 volt. Same load current in each circuit. In each circuit, there are different circuits in our house. So same load current will be there. Ease of repair and maintenance of the circuit. Okay, there should be ease of repair. That means suppose in your study room, one bulb is not working. Okay. So when you will come for repair for that bulb, are you disconnecting everything? Your fan is not working also at that time. If you are repairing, if your bulb is not working, if you are at that time you have switched on your fan, when you are connecting another bulb in that holder, are you disconnecting your fan also?
No, ma'am.
No, ma'am.
No. That means what? You are easily repairing one of the loads. If other loads are working, it is good. Okay. It's not that in one particular room you will the wiring should be such that if one bulb is not working, another fan will not work, another bulb will not work. No, you don't have to do that type of wiring. Okay, this is the minimum requirements. I've told you, na, this is the requirement of a good wiring circuit. Your wiring should be such that will be ease of repair and repair. Easily you can repair it and maintain the circuit. Safety and minimum inconvenience to the consumer. As I have told you, if anywhere you are having any fault or if it is not working, suppose an electrician is coming to your house, your fan is not working, then he has to move that fan only. It should not that it does not mean that everything should be switched off. If he is working on the fan, all the loads should not be switched off. Your TV, fan, your grinder, washing machine, everything should not be switched off. Your wiring should be such that. Okay, your wiring should be such that it should be safety and minimum inconvenience to the consumer. That should be very minimum inconvenience to the consumer. So therefore, the load limited to 800 watt or number of points you must have seen in each room. In your house, you must have seen in each room there are different number of points. Yes or no? A bulb, 2 fans, one AC, or there are a number of points. Yes or no? One is for iron, one is for laptop. Got it or not? So number of points should not exceed 10. Connected is number of points should not exceed 10. Okay, or more than specified. It becomes necessary to have more than one wiring circuit. You will see that how many I will ask you how many number of points are there in one room only. You will see that maximum you connect it, it should not exceed more than 10. If it is more than 10, another circuit you connect it. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, so each wiring circuit is called a sub-circuit. So there are different types of electric wiring. So different types of electric wiring system is, one is your cleat wiring, second one is your casing capping, third one is batten wiring, fourth one is the conduit wiring. These four types of wiring, I will show you the pictures of the wirings. I will give you the slides. You will read the advantages and disadvantages. Okay, I will show you only the, have you seen this type of wirings? This is the cleat wiring, first one. This is the cleat wiring. Here, this one. Have you seen this type of wiring? Tell me, anywhere. I'm
No.
asking to all of you.
Yes, ma'am. In old houses.
Yes, not old houses. You will see that suppose a building is under construction, you will see that this type of wiring. For under construction, they require 1 or 2 bulbs for working at the night. So this type of wiring they use. This is called as cleat wiring. This was not safe also. Understood, all of you?
Yes, ma'am.
Okay, so I have written the advantages, and advantages is it's simply clean and cheap wiring system. Okay, but most suitable for temporary use under construction building or army camping. Army, you have seen army camping, the army camp. They are this type of wiring system they are using. Okay, but disadvantages, they get very fire very quickly. There is always a risk of fire and electric shock. You see. Okay. So these advantages and disadvantages I'm not discussing. Yeah, you will read later on. Okay. Now come to the wooden casing and capping. Have you seen this type of wooden casing and capping? This type of wiring. One is cast, another one is cap. Have you seen it or not? This one. Huh? Have you seen it? Or
Yes, ma'am.
Yes, ma'am.
not seen? Casing capping. Okay.
I mean,
Yeah.
fan making also.
What happened? Have you seen it or not?
Yes, ma'am. I mean,
Yes,
fans.
I'm seeing.
actually.
Yes, ma'am.
Yes. One case is there. One case is there, another one is cap is there. Okay, that is my slide. Yes. You see, one case is there, another one is cap is there. That is a casing capping. Wiring. Okay, here also some advantage and some disadvantage is there. You will go through the advantage and disadvantage. I'm not going details into the advantage and disadvantage. Only 2 to 3 advantages you remember. I have given more than 2 to 3 advantages. Next is batten wiring. Have you seen this batten wiring? Tell me. This type of wiring.
Yes.
Old wiring system.
Yes, ma'am.
Batten wiring is the old wiring system. Yes, most of you have seen. Okay. This use the wooden batten. These are the wooden batten. You'll see these are the battens. This one. Okay. This is the batten. Here. They are made up of wood. That is wooden batten wiring. The last one is your, which is important, that is your conduit wiring. Just wait. This is conduit wiring. Where you have seen conduit wiring? There are 2 types of conduit wiring. There are 2 types of conduit wiring. One is the surface conduit wiring, another one is a concealed conduit wiring. Surface conduit wiring and concealed conduit wiring. Our house, we are using concealed conduit or surface conduit. This is surface conduit. It does not look good, but concealed conduit is good looking. Okay, in our house actually we use concealed conduit wiring. Am I clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Next is different methods of wiring system. Wiring is what? Another 3-4 slide is there. I will complete it. So wiring system, wiring is a process of connecting various accessories for distributions of electrical energy from supplier meter board. Your house, your fan, light, bulb, whatever may be, they are connected to the supplier meter. Okay, because supply is coming to the meter, energy meter. Okay, from there all the appliances are connected. To home appliances such as lamp, fan, or the domestic appliances is known as electrical wiring. That can be used in done in three methods actually. One is a joint box system or T system, another one is loop-in system, another one is staircase lighting system. Joint box or T system I'm showing you. Here you see, this is the joint box, or here you see, this is the main distribution board. Here, from here, you have connected a lamp. You see the lamp is connected. When you switch on this, the lamp will glow. Okay. And here, if you switch on the switch 2, here the lamp 2 will glow. This is the joint box or T system. These joints are made in joint boxes by means of suitable connector or joint cutouts. Okay. Suppose you want that this bulb should work. So we switch on this one. Suppose you don't, that the second bulb will work. This is the switch 2. And understood, this method is suitable for temporary installation and it is cheap. This is loop-in system or looping system. Have you ever observed when you switch on a supply, when you switch on a particular switch, you will see that two bulbs will go, will work simultaneously. Have you ever observed it or not? In our house, your house also.
Yes, ma'am.
Okay,
Yes,
that is a loop-in system. Okay, loop-in system. When you will switch on the supply, the connect wiring will be such that two lamps will glow at a time. Okay. Another one is staircase lighting. Staircase lighting also, you will see that this one I will give you an active assignment and you will tell me. Staircase lighting is, you will observe, you have observed that suppose you are staying in a apartment. You are staying in a apartment. You will see that somebody staying at the ground floor, if he or she will switch on the bulb staying at the ground floor, you will see that at the fourth floor that light will glow. Yes or no? Suppose you are staying at the fourth floor, you want that at the ground there is no lighting, so you can operate that bulb from the fourth floor also. Yes or no?
Yes, ma'am.
Yes, ma'am.
Have you ever
And
observed?
like our bed.
Yes.
Yes, ma'am.
Have you ever seen it or have you ever worked it, or you are telling just a yes, madam? Because I'm
We have in our home also, ma'am.
yes. So that is a staircase lighting. Okay. So that switch can be operated in the both way, two-way switch. That we call it as two-way switch. Okay. You can operate it. It will disconnect it and connect it here so that the bulb will glow. Here also you can do the same thing. Okay. That is a two-way switch. Clear to all of you? I will give you an activity. I will give you a group activity where you will showcase this type of wiring. Now coming to the battery. Different types of batteries are, one is a primary battery, another one is a secondary battery. Another 4-5 slides are there. I will complete it. So primary battery is what? These are primary batteries. What is primary battery? You have seen, you are using in your watch, in your torch. Okay, these are the primary batteries. They cannot be recharged. Once it is depleted, it cannot be recharged. Why? Because primary batteries are made up of electrochemical cells whose electrochemical reactions cannot be reversed. Okay, so these are in the pacemaker, animal trackers, in the children's toys, remote controls, in their primary batteries are used. Okay. Now coming to the secondary batteries. Second one is the secondary batteries. Secondary batteries, there are 4 types of secondary batteries can be recharged. Everywhere, most of the cases, we are using secondary batteries. In your laptop, in your mobiles, okay, in your inverters, all these are of secondary. In your car, in your vehicles, they are all rechargeable batteries, that is secondary batteries. Lithium ion, nickel cadmium, nickel metal hydride, lead acid battery. Okay, can you tell me one question I'm asking, in your vehicle, which type of battery you are using out of this? Which type of battery you are using in your mobile phone? Which type of battery you are using in your laptop? Can you tell me?
Lithium ion.
Where? Everywhere? In all the cases?
In mobile
phones.
Laptops, vehicles,
and
electric vehicles.
See, lithium ion battery is this one. This we are using in where? It is very light in nature. Okay, very light. They are used in mobile phones, in the smart devices. Okay, and other battery appliances used at home. This type of battery is your lithium ion batteries. Now this is what? This is nickel cadmium batteries. The main disadvantage where you are using this type of batteries. Where you are using this type of batteries. This battery is having one disadvantage that it fall a victim of dreaded memory. Have you ever observed in case in your laptop also you will some cases you will observe that once the battery is completely discharged, if you will give charge, it will take some time to immediately it will not switch up if it is completely discharged. That we call it as dreaded memory. Have you ever observed it or not in some device? Observed it or not? It will not work if it is completely discharged. So those batteries, you should not see that it is not fully discharged. Before fully discharged, you have to recharge it. Am I clear?
Yes, ma'am.
That is nickel cadmium batteries. This is metal hydride, nickel metal hydride batteries. This battery is where you are using. They are having very high drain device, very high capacity. This is costlier. This is costlier than nickel cadmium batteries. Okay, because this is having high drain device because of their high capacity and energy density, and they do not fall dreaded memory. See here you see nickel metal hydride chemistry are not susceptible to the memory effect. Tell.
Ma'am, we have a maths class right now.
Oh, 4 o'clock. Okay. I'm leaving.
Yes, ma'am.
Just wait.
Ma'am, where we are using that battery, ma'am?
Just wait.
Where we are using that battery? That high density battery.
High density battery.
Yeah.
It is used in cameras most of the time, HD cameras and DSLRs.
Where you are having very high capacity, you can use that. You can also use nickel cadmium batteries, no issues. But nickel cadmium batteries will be having some disadvantage. Next class, all of you keep calculator. Next class, I will start DC circuit. Okay, you can leave, all of you. Bye.
Thank you, ma'am.
Thank you, ma'am.